Hello and good morning to everyone. Sorry, just my studio door was locked, so I had to wait a little at the outside. Udappal is asking, sir, I have a question. If angle of incidence and angle of emergence are given equal, is it in an equilateral prism? Then what are the values that will be asked to find and how to find it? Please tell, sir. Okay, don't worry. So just a second, let me reduce my volume. So angle of incidence and angle of so you are saying that in a equilateral prism, if angle of incidence and angle of emergence are given, so they can ask you multiple things. First of all, if it is an equilateral prism, you know the angle of prism is A equals to 60 degrees, okay, and this is I, this is E. Now it can be equal, it may not be equal, but you have to remember that minimum deviation is equals to A minus I plus E minus A. So sometimes the question may be easy that they will ask you what is the angle of deviation. They will say that angle of incidence is 20 degrees, angle of emergence is 30 degrees. Okay, sometimes they will ask 20 degree minus X. Then this is what is the value of emergence angle, or minimum deviation. In case of minimum deviation, what is the angle of emergence angle? So these kind of things are maybe asked. So you just remember this is the formula for minimum deviation. For if I equals to E, then they might ask what is the refractive index. Refractive index is sine A plus delta by 2 divided by sine A by 2. So this is the refractive index. So they might ask refractive index is 1.5. What is the angle of what is the value for delta? So these kind of questions are very, very common, and based on question you can solve those questions. Okay, so delta equals to I plus E minus A. That is the first point that you have to remember. And in case of internal angle, R1 plus R2 equals to angle of emergence. So there was once a question that R1 is given some value, and they asking you what is the value of R2. So don't worry, R1 plus R2 is equal to angle of prism. So from there also you can calculate. Okay, duration Manamu, it will be around 1 hour. Okay, I will try to cover some of the questions which I have already solved in the previous classes. So that's how the class is compiled, and it will be basically a revision class. We will not do anything new, because obviously we do not have a lot of time to do anything new. So just go through this class so that you can Amisha is saying, can you please revise all equation? Okay, let me give you, okay, let me have another class. Just a second, give me a second. Okay, so basically here what we are going to do, let me clear about that. We are going to discuss some of the important concepts from these chapters, so that any theoretical question, if it is coming, we'll be able to answer, and some questions also I will be showing you. So basic properties of electric charges. Charges are additive in nature, that means you can add the charges like a scalar quantity. Okay, charges are conserved. The total charge of an isolated system is always conserved. It is not possible to create or destroy a net charge. So remember that charge of an isolated system is always conserved. If it is not done, then you will not be able to add or subtract charges. Okay, charges are quantized. Obviously we know that Q is equal to Ne, and here E is charge of 1.6 into 10 to the power of minus 19. Now if you are following my lecture, you know that there are questions based on charges are quantized and how to solve them as well. They are here. Okay, now so if you see that charges are quantized based on this principle, questions do come, and if you are being asked how many electrons are there in 2 Coulomb charge, or how many excess electron, how many less amount of electrons are there, if the charge is a normal charge like this. Okay, just a second. If charge is normal charge like this, so what you can do, you have to remember that multiply with 6.25 into 10 to the power of minus 10 to the power of 18. Okay, so this is the factor with which you have to multiply to find the amount of charge. But if they give you a value which is multiple of 1.6, you do not use this method. You directly divide by 1.6 into 10 to the power of minus 19, calculate directly the amount of charge. Okay, amount of excess charge particles. So this is how you should approach. If the charge is a whole number, 1 Coulomb, 2 Coulomb, 3 Coulomb, 5 Coulomb, multiply by 6.25. If it is 1.6 to 3.2, 4.8, 6.4, in those cases you divide by 1.6 to calculate the amount of charge. Okay, next is Coulomb's law. Now in Coulomb's law, you have to remember, based directly Coulomb's law they will not give you, but they might give you that we have inserted a slab between the charges. What will be the new force? That the width of the slab will be given half distance, 1/4 of the distance. Okay, remember that for that you have to calculate the equivalent length. How to calculate equivalent length? Whatever x is the width of the slab that is being inserted, dielectric constant is capital K. So in that case you have to remember that if you multiply x with root K, and if you add the remaining portion which is already in vacuum, okay, the remaining portion which is already in vacuum, if you add these two quantities, okay, then you divide it by the same formula of Coulomb's law, you get the actual force. So based on this, there were questions that half of the slab is being inserted, then how to what will be the new force. So be prepared for that. Remember, dielectric slab means the distance becomes root K times the width of that slab plus whatever area is there in the free space. Okay, obviously the constants you already know, 9 into 10 to the power 9. For most purposes, if you don't remember this value of epsilon naught, which is slightly difficult to remember epsilon naught is almost very close to 9 into 10 to the power of minus 12. Generally epsilon naught's value is provided in the question itself. Okay, now let's move on to the next part where electric field is being discussed. Electric field is given by, normally due to a point charge, it is given by 1 by 4 pi epsilon naught Q upon R square. And if you plot the graph of electric field with distance, normally this is how electric field due to a point charge. This is due to a point charge. Remember, this is due to a point charge. Okay, for separate cases we will discuss it, but for a point charge the graph looks like this, and this pattern is one of the most common pattern in KCET. Force acting on a charge in an electric field is Q into E. Okay, now let's see one question. A body has a charge of minus 3.2 microcoulomb. So minus 3.2 is a multiple of 1.6. So directly divide by 1.6 and calculate the amount of excess particles. electrons, protons, whatever it is. A charged particle of mass small m and charge small q is released from the rest in an uniform electric field E, neglecting the effect of gravity, the kinetic energy. So there can be some questions which can be oddly related to electric field and forces. Remember, very important thing is that force is equals to q into A, and that should be equals to ma. Okay, and from there you have to calculate. Some cases they might ask you what will be the distance traveled, what will be the if the force is being asked, directly you can calculate. If they say that what will be the distance traveled, so remember, distance traveled, whatever you are going to use, you have to use this acceleration. For example, in this problem we have to calculate velocity, and kinetic energy is half mv square. You put that formula for acceleration, whatever is the acceleration, use that acceleration to calculate velocity, put that, calculate kinetic energy. Okay, if they ask you distance traveled, you can say that distance traveled is half at square. Okay, just put the value of A and directly calculate whatever is the distance traveled. Okay, now next is the force of repulsion between two identical positive charges when kept in a separation of r. Okay, that's the question I was talking about. Half the gap between the two charges filled by a dielectric slab of dielectric constant 4, then the new force. So first you have to calculate the equivalent length. Initially the force is this, obviously, and then what you have to do, you have to calculate the distance when the dielectric slab is inserted. The distance changes, so what will be the new distance? R by 2 is the width of the slab, root k is the dielectric constant is 4, so root 4 into R by 2 plus R by 2, which is already in vacuum. So remember this, based on this also we have seen questions, so don't ignore this concept. Okay, and then you calculate whatever corresponding force is. Next is electric dipole, another very important concept. This is one of the most favored concept of KCET. So dipole moment points from negative to positive. Okay, and if you multiply any one of the charge with the distance between the charges, that gives you the dipole moment of the dipole at that point. Okay, now you also have to remember very carefully is that sometimes they will give you this distance directly. They will give you this distance directly, and in that case you do not multiply with this extra 2 factor. Okay, extra 2 factor comes only when half distance is given. If half distance is not given, that is midpoint distance is given, in that case you multiply 2a, otherwise do not multiply 2 if they only give you the distance between the charges and one charge. The same concept applied for magnetism as well. Okay, magnetism also, if monopole strength is same as charge. Okay, monopole strength is same as charge, and generally the distance between the poles are given. So in that case magnetic moment is given by mu into 2L. Okay, mu into 2L is the magnetic moment. Now what else? Nothing here. Now let's move on to the electric field due to a dipole. Now remember, electric field due to a dipole on the axis is 2p by r cube, and on the equatorial plane it is minus p by r cube. So from there, if you compare that electric field due to a equatorial plane and axial plane are actually E axial is equal to 2. So E axial equals to 2 equatorial plane. Normally if they add vector sign, there has to be a negative sign. Okay, if they add vector sign, there will be a negative sign. Magnitude wise twice, direction wise opposite. Angle between normal axial plane, the angle is 0. Okay, angle between dipole moment and electric field, angle between dipole moment and electric field, for axial plane it is 0, and for equatorial plane dipole moment and electric field are opposite, so the angle is 180 degree. That's the reason it is minus. Okay, quick, very quick. I do not have the time to read chat. Smoky Washad, you don't need the PDF. Okay, right at this stage you don't need the PDF. Dipole in external field. So if you keep a dipole in external field, you remember that torque equals to P cross E. Torque equals to P cross E, and torque is equals to PE sin theta. Okay, if the magnitudes are given, you just need to do PE sin theta. Theta will be given, P will be given, E will be given. You just need to multiply them, calculate torque. But if they ask you vector wise, okay, vector, suppose they give you that P is represented by this vector, E is represented by this vector, then you have to use this method and multiply, cross determinant method. Okay, you have to solve it using determinant method. Now some students always confuse between cross products. I have seen that in the past. So remember I, J, K. If you are doing I cross J, you will get K. Everything is positive in this cycle. J cross K gives you I. Okay, and K cross I gives you J. So this is the circular way. But if you multiply in the opposite way, suppose you are getting J cross I. J cross I is basically minus K. Okay, so this is minus I cross K. I cross K is minus J. K cross J is minus I. So if you are going in the opposite direction of the given loop, so clockwise means positive, anti-clockwise means negative. If you are going in the opposite direction, it will be negative always. Okay, so clockwise, anti-clockwise. Remember, if you are going multiplying I, J, K, if you are confused, use this circle. That will be very, very helpful. And in this determinant case, you don't need to worry about anything. You just need to multiply using determinant method. Whatever determinant method you use to solve, that is final. Okay, I cap, J cap, K cap will come automatically. Okay, and also potential due to a dipole is minus PE cos theta. Potential due to a dipole is minus PE cos theta. Remember, there is a minus sign. Also, higher the angle, that means theta. For higher theta, potential energy is more. For smaller theta, 0 theta, potential energy is small. So if they give you some angles and they ask you rearrange them according to highest order or lowest order, in that case, remember, smaller the theta, smaller is the value, or smaller is the potential. Higher the angle theta, higher the value. Okay, as theta increases, because theta 90 0 is not the smallest value, because minus PE is more smaller. So theta 0 gives you smallest value, theta 180 gives you maximum value. Okay, and obviously based on the cases, if they give you the maximum potential energy, at what angle potential energy is maximum? Potential energy is maximum at theta equals to 180 degree or 2 pi. Gauss's law, we all know Gauss's law. E dot ds is equal to q by epsilon naught. Electric field, if they give you phi, they ask you calculate phi. So remember that phi is equal to E dot A. If vector form, E dot A, scalar form, EA cos theta. Okay, EA cos theta. Also, one more important thing, that if they give you a weird surface like this, okay, and they ask you what is the flux through inside and outside, remember that whenever you are calculating flux, E dot A is valid when the E into A is valid when it is perpendicular. So for example, in this case, if you want to solve for the upper hemisphere and lower cone, this is the common PYQ. Okay, if you try to calculate using upper hemisphere and lower cone, the angle is not 90 degrees over here. Okay, so you cannot directly apply E dot A. So you have to take the central circle where the electric field line is actually perpendicular. Okay, electric field lines is actually perpendicular to the surface. So you just apply the knowledge that whatever incoming flux is the same outgoing flux through a surface. If there is no charge present inside a surface, incoming flux should be outgoing flux. And if there is a charge present, then you have to use this formula. So remember that phi equals to incoming flux, outgoing flux minus incoming flux. So there was once a question, they gave you a block like that. They said some electric field is here, some electric field is there. What is the amount of charge present? So you have to individually calculate the incoming flux, you have to individually calculate the outgoing flux, and then find the difference between them, and that should be q by epsilon naught. Okay, so this is the way to solve a question where they have given you a surface system. Okay, now let's move on. Application of Gauss's law. Electric field due to a straight uniformly charged wire is 1 by 4 pi epsilon naught 2 lambda by r. If you are comfortable with 1 by 2 pi epsilon naught lambda by r, that is also fine, but major thing is electric field is proportional to 1 by r. Okay, electric field due to a uniformly charged plane sheet is constant, which is given by sigma by 2 epsilon naught. Field due to a uniform charge thin spherical shell, it is 1 by r square, proportional to 1 by r square outside the shell. Inside the shell, it is actually equals to 0. Okay, the same concept is applicable to a conducting sphere as well. Thus, it is not only spherical shell. If it is a conducting sphere, same principle is applicable. Non-conducting sphere is not there in the syllabus. Okay, also, how can you identify the graphs of electric field and electric potential? Very common mistake students make. So electric field inside the shell or conductor is 0, so it does not exist over here. Electric potential, on the other hand, the graph looks same. The graph looks almost same, but it is constant here. Inside the surface, electric potential is constant and it goes like this. Okay, so electric potential is there will be a straight flat line, but for electric field it will start at some point and suddenly it goes to 0. So remember that if there is a straight line, it's potential. If it is falling, it will be electric field. So this comparison graph also came in the past. So now again, this question I have already discussed. Next, look into this. Pick out the statement which is incorrect. So correct statement, you have to be careful in the exam, because sometimes they will give you incorrect statement, sometimes they will give you find the correct statement, so sometimes wrong statement, false statement. So in that case, don't be confused, just read and mark, underline incorrect. Okay, correct, false, true, underline that so that you have a clarity what they are asking you. So if it is an incorrect statement, that means 3 statements are correct, only one of them is incorrect. Okay, so this is just an example problem, but remember, incorrect, correct, false, true, those kind of questions can be tricky if you are not careful. So be careful and answer. If you see those kind of questions, take your time, little extra seconds, and read the question carefully and then answer. Okay, very careful about these kind of questions. So this one also I have explained that angle between dipole moment and electric field at any point on equatorial plane is 180 degrees. A spherical shell conductor of radius 2 cm is uniformly charged with 3 nanocoulomb. What is the electric field at a distance 3 cm? First check is that whether this distance is more than the radius or not. Yes, it is more than the radius, so you just apply normal electric field formula, calculate electric field, you will get full marks, right? Now potential due to a point charge, electric potential due to a point charge is given by, obviously we know that 1 by 4 pi epsilon naught Q by R. Do not make mistake that potential is 1 by R, not 1 by R square. Now if you see the comparison graph, electric field starts at higher point and it falls rapidly to 0, but electric potential starts at a smaller point and goes to 0 slightly slower. Okay, that is the difference between electric field and electric potential. The graph looks almost same. Electric field is proportional to 1 by r square. Electric field is proportional to 1 by r square. Electric potential is proportional to 1 by r. Pattern of the graph is same. Potential due to a dipole. Potential due to a dipole, only thing that you need to remember that potential is proportional to 1 by r square. Okay, p cos theta by r square, but never seen any question, but they have asked you what is the graph of electric potential due to a dipole. So that will be same as electric field. It will be 1 upon r square graph. Okay, so remember that. Now next is equipotential surface, another very common question that comes in the exam based on equipotential surface. An equipotential surface is the surface with a constant value of potential. Work done to move a charge in an equipotential surface is 0. Work done to move a charge in equipotential surface is equals to 0. Okay, now they might give you a complicated diagram, say that what is the work done to move the charge from here to here. The work done will be 0 because obviously potential is constant, and work done basically given by for a single charge work done is given by, what is the formula for work done by a single charge? Work done is basically Q into V. Okay, this is also the formula for potential energy. And if there are 2 points, suppose we have a point A and point B, Okay, and if you are moving a charge from A to B, then what is the work done? Work done is basically charge into potential difference, final minus initial. Okay, final minus initial, that is the work done to move the charge. And electric field is difference in potential by distance. Okay, suppose this is the distance, so difference in potential by distance gives you the electric field. Okay, these are the very common thing. And nature of equipotential surface: for a point charge, spherical, concentric spherical; for uniform electric field, planar, parallel and planar; and for a line charge density, it is cylindrical. Line charge density equipotential surface is cylindrical. Now next, electric field and potential, as I mentioned, it is dV by dl, but if you are writing in terms of difference in potential, it will be final potential minus initial potential divided by distance. Okay. Now next, parallel plate capacitor, very common question that comes from this chapter. Remember, capacitance equals to A epsilon naught by D for air, but if you add a dielectric medium, it will be Ka epsilon naught by D. Okay, it will be Ka epsilon naught by D. Now here is one example problem where they have given you electric field. They have given you 2 points. They said what is the potential energy when the charge is at point B. So potential energy at any point is given by charge into the potential of that point. Okay. Now electric field is final minus initial, and from there you can calculate the work done is the potential energy is VA minus EX. Remember, if you are moving in the direction of electric field, the potential always decreases. In the opposite direction of electric field, potential increases. In the direction of electric field, potential always decreases. This is also very, very important concept to remember. Okay. Two tiny spherical spheres carrying charges are located at some distance. The potential at the center. If they ask you potential at the center, basically you can use this shortcut formula, or you can calculate charges are known. Okay, charges are known. Distance is known. You can directly calculate the individual potentials and add them, or you can use the shortcut formula, which is basically addition of the charges divided by half the distance. Okay, divided by half the distance. So here charges are 1.8 and 2.8. You add them, 4.6. The half distance of 40 centimeter is 20 centimeter. Convert centimeter into meter. Don't forget how to convert centimeter into meter. These are the very common mistakes. I am not teaching anything new. I am just reminding you the mistakes that you generally make. Okay, so make sure you don't forget to convert centimeter into meter. In 99% of the cases, it will be, you have to convert the units. In 1% of the cases, there are some special exception where they you may not require to convert the units, but you will realize that if suppose they give you a problem where units in the question and the units that you require to find are same, in that case you can skip the conversion. Okay. So there are few cases where you have to compare some values. If comparison is there, then you may not need to convert the units. If there is a no comparison, if you have to calculate directly, convert the unit. Very, very important point to remember. Okay. So a parallel plate capacitor charged by connecting by 2 volt across and then disconnected. So when the capacitor is charged and then disconnected, remember, charge stored in the capacitor remains constant. Charge stored in the capacitor remains constant. But if the capacitor is still connected to the battery, you have added something inside in the capacitor plate. This kind of questions are common. If you add something inside it, but the capacitor is still connected, in that case potential is constant. If you disconnect it, charge is constant. If you keep the connection on, potential is constant. Remaining Q is equal to CV, energy is half CV square. You can figure that out. Okay. Now if in some cases this question came only once. If a slab of insulating material 4 into 10 to the power of minus 3 thick is introduced between the plates of the parallel plate capacitor, the separation between the plate has to be increased by this distance to restore the capacity. So this is a formula that dielectric constant, that by which you have to increase the distance. Okay, if you already had a capacitance of say C. Okay, and you added a dielectric medium between the plates. Now you have to increase the capacitor distance so that the original capacitance remains same. Then the dielectric constant is D divided by D minus X. Okay, this is a neat little trick to solve the question quickly. Otherwise, if you do not know this formula, it will take for you ages to solve this question. Okay, an electrician, okay, let's skip this question for now. And circuit based question, if you see a circuit based question, you should feel comfortable. Just remember, in case of capacitors, series and parallel are opposite to that of a resistance. Okay, series and parallel are opposite to that of a resistance. So when the capacitors are in series, they added reciprocally. If the capacitors are parallel, they just get added normally. Also check for visual misunderstanding. For example, here these capacitors, all of them are not in parallel because they are disconnected at this point. So that means these two are parallel. So if you first you have to simplify them. They are in series. One series is known. These two are in parallel. Okay, and then this is the entire system is in series. Okay, so identify that and do not make mistake in the circuit. Also, one important tip: if equal capacitances are connected in parallel, equal capacitances are connected in parallel, say 5 equal capacitors connected in parallel. Okay, in parallel, then equivalent capacitance will be C by 5. If 5 equivalent capacitance are connected in series, okay, in series, then equivalent capacitance becomes parallel 5C, series C by 5. Okay, if 5 capacitors are connected in parallel, they just get added. You don't need to add them individually, you just multiply by 5 to calculate. If 5 are in series, you don't need to calculate 1 by C1 plus 1 by C2, directly calculate using C by 5. So these are the direct formulas, and many cases it might save you some seconds of time. Circuit based problem, if you see a circuit based problem like this, here you have to remember that find a point. So this is an infinite circuit based problem. If you see, find a point where if you disconnect the circuit looks exactly the same. Okay, if the total resistance of the circuit is R, the portions that you have cut, that same portion, because it's infinite, will have the same resistance. Now you calculate the equivalent resistance and then equate with the same value that you have taken for this portion. Okay, so this was the symmetric point. So if you cut it from here, you will see that the circuit looks same. So this part should have the same resistance as the original entire superset. Now this subset has resistance R. The superset also have resistance R. Now you find the equivalent resistance. There will be a quadratic equation and you have to simplify it. Lengthy question, but you can solve it if you know the process. Okay, Ohm's law. Alternating form of Ohm's law is important, not the direct V is equal to IR. V is equal to IR based questions, so we have already seen, right? But J is equal to sigma E based questions are common. Remember, sigma is called conductivity. Rho, on the other hand, is called resistivity. The relationship between rho and sigma is rho is equal to 1 upon sigma. Rho equals to 1 upon sigma. Okay, so rho is equal to 1 upon sigma. Guys, stop chatting. You are most of you are here just discussing about which college. Your college will be decided later. You will not be able to cheat in the exam even if you find a friend there. Okay, that is my guarantee. So if you are thinking, sometimes it gives you a confidence, okay, my friend is appearing exam from the same center, but other than that, now resistance and resistivity. Resistance and resistivity are also important. Resistance depends on rho L by A. Obviously, formula we know. Rho is resistivity, L is length, A is area. Okay. Now sometimes they might ask you, if you change the length to 2L. If you change the length to 2L, what will be the new resistance? So find the factor by which the length is changed, and remember that final resistance is N square R. Okay, N is the factor by which the length is changed, double, tripled, quadrupled. So based on that, value will be decided, and then you have to just use n square r to find the final resistance. Sometimes they give you percentage changes. Length is increased by 50%, length is increased by 10%. In that case, if it is increased by a percentage, you take 1 and add the percentage at decimal. Okay, so 10% means 1.1, 20% means 1.2, 50% means 1.5, 200% means 1 plus 2, that is 3. 200% increase, length is increased by 200%. Okay, then it will be 1 plus 2, that is 3. Okay, if it is less than 100, you can always take it as a decimal. If it is more than 100, then you have to add the numbers. Okay, 200% means 2, 500% means 5. Okay, add those numbers. This will also be very, very handy, not only for this kind of questions, for any other questions. If you see a percentage based question, always remember that the factor will be 1 plus the decimal. Okay, now next is drift velocity. Drift velocity is basically given by Vd is equal to minus e tau by m. Now this is very important. I is equal to NE Vd, and out of that this A into Vd term is constant. Okay, for a given conductor, no matter whatever is the shape of the conductor, if current is constant, A into Vd is always constant. It is like, it is called equation of continuity for electric current. Okay, area into the drift velocity is constant. Area into drift velocity is constant. Mobility is drift velocity per unit electric field. They might give you mobility value is some value. Okay, drift velocity value is some value. Then what is the value of electric field? Or electric field value is, say, electric field value is Z. Then what is the value of mobility? So they might give you multiple questions based on this. Just remember, mobility is drift velocity divided by electric field. That's it. Okay, even any questions you can solve. And tau is relaxation time. The relaxation time is inversely proportional to temperature. Higher the temperature, smaller is the relaxation time. So this is also one important point. Okay, so increasing temperature, relaxation time decreases. Next, limitations of Ohm's law. I don't think there is anything here to learn. Series combination, parallel combination, we all know, if the same number of resistances connected in series, the equivalent resistance becomes N into R, and if same resistances are connected in parallel, the equivalent resistance becomes R by N. Okay, so this is the shortcut formula for series and parallel. Next, electrical energy. Energy is vitamin VIT, and power is Vodafone Idea. Okay, VI. Power is VI, energy is vitamin. Okay, and other formulas are I square R, V square by R. Now based on the case to case, we might use these two equations, because remember, resistance for a given circuit is constant, voltage and current are not. So if voltage and current are not, if you want to find the power with respect to change in voltage, you have to use V square by R, not VI. VI is only when you know V, you know I, you want to find the power, you can use this V is equal to VI formula. So this is also not required. Electric cells in combination, cells combinations in series, everything gets added. In parallel, remember this formula, this is much more helpful than the formula given in your textbook. Okay, so epsilon 1 by R1 plus epsilon 2 by R2 plus epsilon 3 by R3 divided by 1 by R1 plus 1 by R2 plus 1 by R3. Generally they will give you two cells. So in case of two cells, epsilon 1 by R1 plus epsilon 2 by R2 equals to 1 by R1 plus divided by 1 by R1 plus 1 by R2. That is the formula to calculate equivalent EMFs. Okay, and R equivalent is same as the parallel resistance formula. Okay, now if they say that a certain number of cells are connected in series, one of them is connected in reverse order or wrong order. So wrong order means reverse order. So you have to remember, suppose there are total X number of cells, okay, 1 or 2 are wrongly connected. Suppose they have given you 10 cells are there, 2 are wrongly connected, then how many are properly connected? Properly connected is 8. Okay, properly connected is 8. How many of them are wrongly connected? Wrongly connected is 2. So total equivalent EMF will be 6E. Okay, equivalent EMF will be 6E. It will not be 80. Okay, you have to subtract the portion that is wrongly connected. First find correctly connected, then subtract the wrongly connected ones to calculate the total EMF. Okay, this is also very tricky, and students make mistakes. They forget to subtract the portions which are wrongly connected. So correctly connected minus wrongly connected to find the total EMF. And current in the circuit is equivalent, epsilon equivalent divided by R plus R equivalent. In some cases they might not give the resistance, so it will be simply epsilon equivalent divided by R equivalent directly. No need to add R if it is not provided. Next is Kirchhoff's laws, junction rule and loop rule. Junction rule is based on conservation of charges, loop rule is based on the conservation of energy. Okay, junction rule based on conservation of charges, loop rule based on conservation of energy. Okay, junction rule sometimes called current law, loop rule sometimes called voltage law. Okay, and also in case of junction rule, remember that all the currents are basically, there is an example here. It is an example of junction rule as well as a loop rule. So if you see over here in this diagram, okay, here 2 ampere current is being coming. Okay, and if you see here, nothing, no other current is mentioned, and here directly they are giving 1 ampere and 3 ampere exiting the circuit. So 2 ampere is coming, so 2 ampere will pass here, it will be added by some current from this side, and then it will pass here, and total current here is 4 ampere. Why 4 ampere? Because 1 plus 3 must be equals to 4 ampere. Okay, so 1 plus 3 must be equals to 4 ampere, but up to this point, how much current was passing? 2 ampere. Up to this point, how much current is passing? If you see in the diagram, up to this point 2 ampere is passing. Suddenly after it crosses this point, okay, the current becomes 4 ampere because there is no other junction here. So that means the current being added from this junction is 2 ampere. Okay, so 2 ampere current is being added through this. So you have to first analyze using Kirchhoff's current law, then you have to apply Kirchhoff's voltage law. Kirchhoff's voltage law, I always recommend that you take a very simple approach. Individually resistances first based on the direction, okay, and then take the battery on the right hand side, so that positive negative confusion does not remain. Okay, so very simple rule that you go through the resistances first, and once this resistance is done, okay, this is, we are going here in this question they ask you find Vg minus Vh. Vg here, Vh here. If you are confused, you can add a imaginary battery like this. You can add an imaginary battery like this, okay, and you say that, okay, there is a battery of Vg minus Vh over here. Okay, so this is a battery actually. This battery is sending current in this direction. Obviously, Vg minus Vh means obviously G to H. Okay, now when we are going from here to here, 2 ampere into 4 ohm. 2 ampere into 4 ohm. Okay, so this is 8. 2 ampere into 4 ohm is 8. Next is 2 ampere. Another same 2 ohm passing through this, so 2 into 2. Now when you are going from here to here, if you see that the direction of current in the upward direction, because we figured out the current must be added so that we get 4 ampere, that means it must be in the upward direction. So here we are going in the upward direction, so that's why our loop starts from G, ends at H. So when we are going in this direction, this must be subtracted. So that's why minus 2 into 1. And that should be equals to your imaginary EMF plus this 3 volt. Now why we are adding this 3 volt? Throughout the process we are going in this direction. What is the direction of this cell when it is trying to send the current? It is sending the current in this direction. Okay, the cell is sending the current in the direction through which we are moving. Okay, we are moving in the same direction as the cell. That's why on the right hand side the cell is positive. Same as our imaginary Vg minus Vh, this is also positive. From this you just simplify, calculate Vg minus Vh. So this not necessarily be same question, but remember, if you are applying Kirchhoff's laws, First, calculate the resistances. First, obviously, first step is Kirchhoff's junction rule. Calculate the current in all the junctions. Once that is done, you apply voltage law. Very simple. Individually resistances first. Second, whatever cell is connected in that loop, if we are going in the direction of the current, then EMF will be positive. If we are going in the opposite direction of the current, then EMF will be negative. But that will be on the right hand side, equals to sign. Okay. Very simple. Now let's move on. This kind of patterns are called Wheatstone bridge. This kind of pattern is called Wheatstone bridge, and this is also again common pattern in KCET exam. Now remember that if this by this is equal to this by this, then this is in balanced condition. No imbalanced Wheatstone bridge is going to come. The balanced Wheatstone bridge is only going to be there. Either straightforward Wheatstone bridge diagram or this kind of Wheatstone bridge diagram. Okay, so if this is like this, and remember, if there is a complicated circuit, there are one more possible diagram of Wheatstone bridge, but if there is a complicated circuit, remember there is a high chance that this is a Wheatstone bridge. Okay, any complicated circuit, there is a high chance it will be a Wheatstone bridge. That means if this by this and this by this condition satisfied, no current passes through this, no current passes through this resistance, means you can simply remove the resistance and you calculate the equivalent resistances. And if all the resistors in a Wheatstone bridge except the central one are same, okay, central one does not matter anyway. If all the resistances in the Wheatstone bridge are same, then the equivalent resistance is exactly equals to the value of one single resistance. So this entire circuit is basically resistance equals to R. Similarly, if you see this one, entire resistance of this circuit is also equals to 2R. Okay, every resistance is same. If every resistance is same for a Wheatstone bridge, resistance exactly equals to the value of one single resistance. If it is not, suppose this is 2R, this is R, this is 4R, this is 2R, then you have to calculate. Then you have to calculate, there is no other option. This is also a balanced Wheatstone bridge. 2R by R equals to 2, 4R by 2R is also equals to 2. So in this case, you have to calculate the equivalent resistance. Okay. Next, move on. A wire of resistance 3 ohm is stretched to twice. As I mentioned, if they are being mentioned twice, thrice, 4 times, 5 times, 50%, 100%, then you have to use this factor, and whatever strategy I told you to convert percentage into decimals or percentage into a number, then you add that number over here and you calculate the equivalent resistance. Next. Now V versus I graph. V versus I graph is also common. For normal conductor, V versus I graph is a straight line. Okay. For different other conductors, it can be other curved line. But for normal conductor, V versus I graph is a straight line graph. Also, you have to remember one very important thing. If you try to calculate slope of V versus I, V is x-axis, I is y-axis, then the slope of this graph is 1 by resistance. Slope of this graph is 1 by resistance. Okay, it is not resistance, it is 1 by resistance. But if they change the axis, sometimes they change, I versus V graph is given, then slope of this graph will be directly resistance. So this you need to be little careful. If it is V versus I, then slope of the graph is 1 by resistance. So they will say that if we increase the temperature, what will happen to the slope of the graph? If we increase the temperature, resistance increases, slope decreases. Okay, if you increase the length of the wire, okay, resistance increases, slope decreases. So based on this increase or decrease kind of questions might come. Okay, some of the this is a complicated circuit diagram, as I mentioned, this complicated circuit diagram, but this is not a Wheatstone bridge. Okay, but there is a shortcut to solve this question. If you see that there is a straight line, if there is straight line, that means there is no resistance here. You can ignore any resistances connected in parallel along this line. So the combination of these resistors are also parallel. The combination of these two resistors are also parallel here. So all these resistances will actually not play any role in this circuit. So this is also a typical visual illusion question where a lot of resistances are shown here, but these resistances do not participate in the current conduction. Now explanation will take time. I have explained it multiple times, but just remember that if there is a straight line, this is called short circuit. If the short circuit is there, okay, no current will pass through any parallel combination. Series combination, they will pass. Okay, series combination current will pass, but any parallel combination current will not pass through them. Okay, now let's move on. This question I have already discussed. Now Lorentz force, let's look into Lorentz force. I will take another 30 minutes, guys. Another 30 minutes I will wrap it up. When a charge moves through a space having both magnetic and electric field, it experiences a force. Now the force due to electric field is given by Q into E. Okay, force due to a magnetic field is given by Q into V cross B. This is the vector product, V first, B second, V first, B second. Okay, if they give you force, and they say what is the velocity, you cannot directly simplify using direction method. You have to take the vector of velocity A I cap plus B j cap, do the cross multiplication, then you can compare and find the values. Okay, do not use directional method. There was one comment came from someone of you saying that, sir, you have solved it wrong, directional analysis showing this. You cannot use directional analysis because it's a vector quantity, and I cap j cap can give you multiple different directions. So it is not only I cap and j cap, only x axis and y axis. Okay, if it is x axis, y axis, there is a way that V, B and F, they are mutually perpendicular. But otherwise there will be no directional analysis. You cannot do it. You have to take V value as A I cap, B j cap. Okay, so you take V as A I cap plus B j cap. Okay, generally B value will be given, F value will be given. So find V cross B and then compare it with F and calculate A and B. Okay, that is the only method to solve. Total force on a charge is Q into, once it came slightly lengthy problem where you have to first calculate V cross B, then electric field E was given, add them, then find the magnitude, but that was a long process, slightly lengthier question. If you see those kind of questions, take those questions last. Okay, one very important exam strategy, guys. If you are answering questions in the exam, suppose you open the question paper, you see that first 5 questions are difficult and you are not able to solve, you are started panicking. Do not panic. I request, do not panic. There will be plenty of questions that you will be able to answer. Have that confidence within you. So if you open the question paper, first 2-3 questions in the first page or next page, this question I am not able to solve. So do not panic. Open 3rd page or 4th page. Okay, go to question number 30 first. Okay, ignore first 30 questions directly, go to question number 30. Find the question that you will be able to answer. Okay, start with that question. If you start solving 4-5 questions straight away, your confidence will boost immediately. You will come back to your original practice. Remember, you have done hard work for at least last few months, maybe not before that, but at least last few months you have done a really good work. Okay, do not forget that. Do not forget your hard work. So if you are not able to answer first few questions, do not panic. The paper that you have received, first few questions are difficult. Okay, because there will be different patterns. Each student will have different questions to start with. Starting questions will be different for every one of you. So do not panic if you receive a paper where first questions are difficult. So you go to a page, you go to find a section from where you can start, answer those questions first, then you come back to the same questions that you felt difficult. Now you will be able to answer those questions as well. Okay, so do not panic if you are not seeing any common question or any questions that you are not able to solve at the beginning. So that is very important technique. Remember, out out of 60 questions, you should be able to answer 40 questions with 2-3 months of preparation. Okay, 2-3 months of preparation. If you have started preparing for your PU board, that also count for preparation for KCET. Don't worry, you are thinking that sir, I have only started after PU board. Don't worry, if you are preparing since your PUC exam, that also counts into your KCET exam preparation. Okay, so if you find difficult question paper, don't worry too much about it. Just move forward, find a place from where you can start, and then you will break the exam. Don't worry, that is my advice to you. You will all do really well in the exam, I can guarantee that. Okay, those who have started 1 week back or 5 days back or just yesterday, for them I will not take guarantee, but those who are here staying with me, listening to my lectures regularly, at least for last 15 days or when we started our 15-day challenge, they will be doing great, I can guarantee that. Okay, they will be doing great, but just have some faith in you. Okay, because sometimes it is very common for you to have being anxious. Okay, exam hall pressure will be there, I cannot deny that. Okay, unless and until you are a toppers, those who are preparing for really hard for 1-2 years of preparation last year, okay, they started at 11th, now they are in the 12th also, they are doing really good. Those students will have confidence in them. But even if you are not as prepared as them, you still can compete against them by just gaining your confidence, just removing your anxiety. And once you start solving a paper, okay, your anxiety will be gone if you are able to solve those questions. So be little bit anxious is okay, but do not start crying in the exam, do not be panicking in the exam. Okay, because this is your day, remember, tell yourself, today is my day, I will be doing great no matter what. Okay, promise. Now okay, now let's move on. So force on a current carrying conductor is given by BIL sin theta. Okay, force on a current carrying conductor is given by BIL sin theta. Now if they give you that theta equals to 0, force is also equals to 0. So if the conductor is in the same direction as the magnetic field, force acting on a current carrying conductor is 0. Okay, also one more thing, it is L cross B, not B cross L. So as just for your information. Now this is also very important. Everything here, radius of the circular path mb by qb, angular frequency omega is equal to qb by m, time taken for one complete revolution is 2 pi by omega. So r is equal to mb by qb, angular frequency omega is equal to qb by m. So do not confuse it. If you are confused, go back to the basics. Centripetal force equals to Lorentz force. Centripetal force equals to Lorentz force. Compare these two and calculate radius, and in case of omega, v is equal to r omega. So if you forget these equations, not uncommon, because I sometimes myself get confused between r and omega. Okay, and time period is 2 pi by omega. Do not remember anything else, because this formula is valid for all types of time period, and frequency is equal to 2 pi by omega. This is also valid for all frequencies. Okay, now circular current loop, another important, very important concept for KCET. Okay, lot of questions came in the past, almost one question, almost a year is coming from these concepts. So magnetic field at the axis, magnetic field at the axis of the circular loop is n mu naught I r square divided by 2. So I write it like this: mu naught by 2 n I r square divided by r square plus x square to the power of 3 by 2. Generally it will be a comparison question. Okay, sometimes they might say that we have a wire of n number of loops. Okay, now we rewind it to a small n number of loops. What will be the new magnetic field at the center? So in that case, magnetic field at the center is mu naught by 2 I by r. Okay, and n mu naught by 2 I by r. Now here, if one coil is rewounded into a smaller coil or larger coil, remember that total length of the wire should remain same. Total length of the wire should remain same. Total length is what? Total length is 2 pi r. Okay, so in this case suppose capital R, 2 pi capital R. In this case suppose small r, so 2 pi small r. So both should be equal. Okay, the length should be equal. Okay, sorry, just a second. So suppose number of turns are n, so length will be n into 2 pi r, and here it will be small n into 2 pi r. Okay, so capital N into r equals to small n into small r. So this is how you should approach a question. Capital N, number of turns into radius equals to number of turns into radius. Okay, if they give you diameter, divide it by 2 to convert it into radius. Okay. Next, when you are calculating magnetic field due to current carrying wire, for straight wires, how to find the direction of magnetic field? Direction of magnetic field is important. How to find the direction of magnetic field? Direction of magnetic field, you take your thumb in the direction of current, then your fingers will point the magnetic field due to a straight wire. For a circular wire, you curve your finger in the direction of current, then your thumb will point the direction of magnetic field. Okay, and magnetic field due to a straight wire, straight infinite wire, magnetic field is given by mu naught by 2 pi I by r. Same formula, almost same formula as a circle. Only difference between circle and straight line is there is a extra pi. Okay, so at the center of a circular coil, 2 pi is missing. In case of straight wire, pi is there. Okay, otherwise the formula for a circular wire and a straight line wire are same. Now in some cases, if you see that the circuit is not complete, half of the circle is there or quarter of the circle is there. So for complete circle, the formula is mu naught by 2 I by r. If the circle is half, you have to multiply half. If the circle is 3/4, you have to multiply by 3/4. If the circle is only quarter means only 1/4 is there. Okay, quarter means like this. Suppose this is the circuit they have given. So in that case, it will be 1/4. For a straight wire, okay, you have to always remember for complete wire it is mu naught 2 pi by r. Okay, in case of half line, here it is only half infinite. That means it is infinite on this side, it is finite on this side. There is nothing present here. So you have to multiply by half. Okay, for example, if they give you a circuit like this, okay, so this is the magnetic field. So calculate the magnetic field at this point. So if you are going in the direction of this, so magnetic field due to this wire will be 0. Okay, magnetic field, if you join the point where you are finding the magnetic field, okay, you should remember that if it is going towards it, magnetic field will be 0. This is a half infinite wire, this is a quarter current carrying wire. Okay, so magnetic field due to this wire is into the page of the paper, right? This is the direction, so it will be into the page of the paper, and for this wire it will be also into the page of the paper. So you just need to take quarter of this and half of this, add them, you will get the total magnetic field. Okay, now if speed and magnetic field is given, remember it is V cross B. Now also remember one very important fact is that if V and B are perpendicular, in Lorentz force based problem, if V and B are perpendicular, that is the particle is executing a circular motion. If the particle is executing a circular motion, the magnitude of velocity remains same. The magnitude of velocity remains same. Okay, only direction changes. Magnitude of velocity remains same, only direction changes. Okay, so if they ask you what will be the velocity after certain amount of second, you calculate where the particles will be, and then you use the normal vector geometry to solve it. Okay, that can be a little complicated if you have not solved it, but remember that magnitude of the velocity will remain same if it is rotating in a circular orbit. Okay. A proton and an alpha particle moving with the same velocity. So proton and alpha particle based questions are common. It can come from moving charges chapter, or it can come from dual nature of radiation and matter chapter as well. So whenever proton and alpha particle deuteron is coming, remember that proton is basically having one charge, one mass. Alpha particle having two charges, 4 mass. Okay, so mass of alpha particle is 4 times mass of proton. Okay, for charged particle for deuteron means 1H2. Mass of 1H2 is twice of a proton. Okay, charge for deuteron is E, charge of alpha is 2E, charge of proton is E. Okay, you just remember these things and that will be beneficial. Okay, now let me move on to something, another important chapter, not here, this one. Okay, mirror equations. So mirror equation, 1 by V plus 1 by U is equal to 1 by F or 2 by R. Okay, remember 90% questions, if it is coming from mirrors, there will be highly likely that object is placed at R, the image will also be formed at R. Okay, so object is placed at R, image will be also placed at R. That means if focal length is given, remember 2F is the radius of curvature. 90% chances is that. Okay, and also magnification in case of mirrors is minus V by U. Okay, for lens makers equation, 1 by F equals to N2 minus N1, 1 by R1 minus 1 by R2. This 1 by F is also power of the lens. 1 by F is also called power of the lens. Okay, so N21 minus 1, 1 by R1 minus 1 by R2. Okay, so lens makers equation, one very important point, if the outside portion is air, you can directly use the refractive index of the medium. If outside medium is not air, you have to divide by the outside medium's refractive index to find this value. Okay, so they might say that one refractive index of lens is X in air. What will be the refractive index when it is immersed in water? Okay, so you have to divide by the refractive index of the surrounding to calculate N21, and then you can find the focal length. Okay, now lens equation, 1 by V minus 1 by U is equal to 1 by F, and again in this case also many times it was asked V and U are actually 2F. Okay, that is at this location. What is the speciality of these locations? That at these locations object size, image size becomes same. Okay, object size, image size becomes same for these two locations, for mirrors as well as in case of lenses. Now magnification is given by V by U and power is given by 1 by F. Okay, now one important part, if you cut a lens along the principal axis, power focal length does not change. The lens will still behave like a convex lens and power and focal length will remain same. But if you cut a lens along the perpendicular line, okay, that is the diameter of the lens, then power becomes half, focal length becomes double. Okay, power becomes half, focal length becomes double. And another point that you might forget, that if focal length is given in centimeter and you are trying to find power, remember you have to use 100 divided by focal length. 100 divided by focal length, because power is always calculated when focal length is expressed in meters. When focal length is expressed in meters, you can calculate power using 1 by F formula. If it is in centimeters, 100 by F. Remember, it will save some time for you. Okay, combination of thin lenses, if lenses are kept in contact, equivalent focal length is given by this, F1 F2 by F1 plus F2. Power just gets added. Power simply gets added. Now refraction through prism, someone was asking at the beginning. So angle of incidence is given by A plus delta M by 2. Delta M is equal to 2I minus A. Okay, angle of refraction is R is equal to A by 2, and refractive index equals to sine A plus delta by 2 divided by A by 2. Now optical instruments, magnification in a microscope, L by FO plus D by FE. L is the length of the microscope. D is the minimum distance of distinct vision, which is 25 centimeter. Okay, and length of the microscope will be given to you. Okay, in case of telescope, it is FO by FE. Also, one more important thing for telescope, the length of the telescope must be FO plus Fe. Okay, this just have a look at this. This is very common in exam. FO, Fe is given. What is magnification? What is the length? Okay, length is given. They ask you which of the following combination will give you a magnification of certain value. So length will be FO plus Fe, and magnification is FO by Fe. Okay, primary or objective of each cases, they will form real, enlarged and inverted images. Okay, in all cases, microscope as well as telescope, the objective will form real, enlarged and inverted image. Okay, now here as there is a funny question. You have a lens, you cut it from the center and then you merge it like this. What will happen? Nothing will happen. This will still behave as a convex lens, and this convex lens will have exact same focal length as the original one. Okay, if you cut the lens and rearrange it, the focal length does not change, the nature of the lens does not change. It might be happening for a convex lens, it might be happening for a concave lens. If the concave lens is also cut like this, okay, the concept is very simple. If you cut it from the middle, okay, focal length becomes double, power becomes half, always. Okay, now if you cut the lens like this and they said, okay, now we have joined it like this, what will be the nature and the focal length? Nature and focal length will remain same, it will not change. It will still be a concave lens and the focal length will still be the same value. Now power based questions, you have to remember power is given by 1 by meter. So whenever you are solving questions, power based questions, the answer should be in meter. If you want to convert it into centimeter, you have to multiply by 100 to convert it into centimeters. Okay. Now path difference and phase difference. Path difference is given by x d by d is equal to x lambda. So here you can calculate path difference, x equals to n lambda d by small d. Okay, path difference is n lambda d by small d. So if they say that what is the distance from the central fringe? Central fringe is x equals to 0. Suppose this is x equals to some value. Okay, so x equals to n lambda d by d. So if they say that two fringes overlap means their corresponding x's should be same. X for say n and n plus 1 overlap. So this equals to the function for the second one. Okay, phase difference is 2 pi by lambda into x. 2 pi by lambda into x. Phase difference is 2 pi lambda into x. Okay, 2 pi by lambda into x will give you the phase difference. Now for destructive interference, almost same, only there is a n minus half is there. N minus half is there. Formula is same, x equals to n minus half lambda d by d. Okay, instead of n it becomes n minus half. Now Malus law, one of the most asked law of KCET exam, where I is equal to I naught cos square theta. Remember 2-3 important parts. When light is falling on a polarizer, polarizer, what does it do? Polarizer polarizes the light. Okay, light, generally incident light, has lot of electric fields. Okay, polarizer arrange them in a particular direction, remaining fields all absorbed. Okay, when intensity of light I incident on a polarizer, the light which is coming out will be I naught by 2. This is the first polarizer. From second polarizer onward, okay, no matter how many polarizer are there, okay, second polarizer onward, it will be applicable using Malus law. If the angle between two polarizer is say theta, so it will be I naught cos square theta. Here I naught is actually I naught by 2. Okay, if all light is already polarized, you can start directly by using this formula. But if the light is not polarized, it is falling on a first polaroid. First polaroid will reduce the intensity by half. Very, very, very important. Okay, first polarizer will reduce the intensity by half, and then onwards you have to use Malus law, I naught cos square theta. Okay. Now photoelectric effect, I will give you the graphs of photoelectric effect. This will be the last topic. So effect of intensity versus photoelectric current is a straight line. Intensity versus photoelectric current is a straight line passing through the origin. So intensity of photocurrent depends only on intensity. Photocurrent depends only on intensity, whereas kinetic energy of the electrons depends only on frequency. Kinetic energy depends on frequency. Photocurrent depends only on intensity. This kind of graphs will be shown to you. So remember, this is the stopping potential. Stopping potential for same frequency is same, for different frequencies it is different. Okay, if this kind of graphs are shown, then whoever has higher current means higher intersection with y-axis, that will have a higher intensity. Whoever are below, they will have lower intensity. Okay, so intensity graph is this, and in case of frequency, whoever has a higher cutoff in the negative axis has higher frequency. Whoever has a smaller cutoff will have a smaller frequency. Okay, so frequency, based on frequency the cutoff increases, based on intensity the cutoff increases. Okay, clear? Now these are the equations for Einstein's equations. Okay, EV naught is equal to h nu plus nu naught. EV naught equals to h nu plus h nu naught. Okay. Now stopping potential versus frequency graph looks like this. Stopping potential versus frequency graph, it is also a straight line. So between this graph and photocurrent graph there is a confusion between students. They confuse which one is what. Okay, photocurrent versus intensity is a straight line passing through the origin. Stopping voltage divided with respect to frequency, it's a straight line, but it is not passing through the origin. There is a intersection over here. Okay, there might be some cases the slope of this line was asked. Okay, the intersection was asked. We have seen some questions like that in the PU exam. Okay, so basically you have to use this equation. Okay, this is y, this is x. So slope will be V naught equals to h nu by E plus phi naught by E. So this is the slope, this is the intersection. This is slope, this is intersection. Okay, y is equal to mx plus c. Okay, if you are confused, use the basics. Go back to the basics. Now one very important formula for all questions based on de Broglie hypothesis and in PU1 chapters as well, momentum and kinetic energy. Momentum is equal to square root of 2mk. Kinetic energy is given by p square by 2m. Kinetic energy is p square by 2m. Momentum is p is equal to square root of 2mk. There might be many questions where they say moving with same kinetic energy, moving with same momentum. Moving with same momentum, kinetic energy can be calculated, but de Broglie wavelength, they will say that moving with same kinetic energy. If they are moving with same kinetic energy, corresponding momentum will be 2mk. Mass is important. Okay, mass is important. So square root of 2mk. Okay, and for a photon, okay, the momentum is E by C. Momentum is E by C. Okay, and in some cases you may require to use this formula that energy of a photon is given by h nu. Okay, and it will be hc by lambda. Okay, and lambda will be given in nanometers. So in that case you can use one shortcut trick. hc equals to 1240 electron volt nanometer. So if you put this value over here 1240, suppose the wavelength is given 600, you don't need to do anything else. You simply cancel and calculate whatever is the value of energy. Okay, so it will be calculated in electron volt. The unit will be in electron volt. Okay, you don't need to put the value of H and C. H and C might be required if they ask you electric energy in terms of joules. If they are given in terms of electron volt, you can always use Hc is equal to 1240. And for simpler calculation, sometimes we even approximate 1240 as 1200 based on questions to questions, but this can also be approximated to this value. So this is also very, very handy to remember. Okay, so here, for example, here is a question: 60 watt source emits monochromatic light of wavelength 6 to 2.5 nanometer. The number of photons emitted. So in this case, what we have used? We have used directly. We have used the conversion, and then we have simplified it. You can do that. You can directly use the value of h as well, but many cases hc should be very, very beneficial. Okay, lambda is h by p. Already know. Okay, so this is the end of the lecture, guys. I wish you all the best for your exam, and as I mentioned, if you are confused, it is very common to get panicked, to get confused during the exam. Remember, very, very important part is that I want to conclude that in the 60 questions that you are going to have, there will be 40 questions solvable for everyone. Okay, if you are preparing for 2-3 months, you should be easily able to answer these 40 questions. Remaining 20 questions, what you will be able to do, 10 questions will be slightly tricky and but solvable, tricky but solvable. Okay, remaining 10 questions will be hard. If you are preparing for 2-3 months, you may not be able to answer these 10 questions. Okay, if you are preparing for longer than that, definitely you will be able to answer some of the 10 questions as well. Okay, but if you are not able to solve those questions, don't worry. Take a very scientific guess. So there are option 1, 2, 3, 4. Okay, first you eliminate. If you want to guess, how to guess? So you have to eliminate the extreme points. Extreme point means too low and too high. Too low and too high you eliminate. Between the remaining two options, you have to take a guess of 50-50 chance. Okay, logically sometimes you might be able to understand, logically sometimes you may not be able to understand. There is one more trick, is that you see some cases what happens is that the values are repeated in the option. Suppose this is 0.2, this is 2, this is 4, this is 5. So you should know that if the values are given like that in the option, the answer likely to be between these two. Okay, suppose there is given a 0.4 here. Now you see that 0.2 and 0.4 are given, so most likely this should be the answer. So there will be a pattern in some options that some values are repeated, and in some cases 10 to the power of values, decimals, they are repeated. So you have to first take the most common option. Most common option means the common value and common decimals. Okay, so they will give you to confuse you, whether if you make a small mistake you might get 0.4, if you get a small mistake you might get 2 also. So that's why they have given you the options like this. So most likely the common answer will be this. Okay, so this is also a way of guessing the answers. Okay, if all the answers are random, you cannot guess it. You have to take this scientific way of guessing. Okay, obviously there is a 25% chance only that you will be correct, but still that 25% can give you few marks if you are doing it correctly. Okay, but this kind of guessing is almost certain. If you see this kind of options, almost certainly it will be correct, because they just give you to confuse you, or if you make a mistake to take an advantage of that, they have given the options like this. So first find the common value, then common decimals, common units, some cases. Okay, so you do that and you will be fine. Okay, and also do not panic, stay confident, you will be doing great. So all the best for your preparation. Okay, yes, all the best. Raju, yes, Tukka strategy is not for you. If you are confident, if you want to solve, definitely I have done the Tukka strategy at the last day of my lecture. I have not taught any Tukka strategy throughout the lecture. I have given you some hints, some ideas about it, but Tukka strategy is obviously for the questions that you are not able to solve in the exam. Otherwise, Tukka strategy you cannot use all 60 questions and hope that I will use Tukka strategy and I will score 45, 40 plus marks. No. Tukka strategy is only reserved for the 10 questions that you are not able to solve. Okay, for those 10 questions, this is the Tukka strategy. Otherwise, Tukka strategy is not recommended by me as well. Okay. So what if the answer is high number option? Suppose answer is option D. Yes, there are chances, of course there is a chance that the answer will be high number options. Okay, but 90% cases those questions you will be able to solve. Okay, for some questions that you are not able to solve, there is a chance that the answer is hidden between the maximum and minimum value. Okay, so that is the questions that you are not able to solve. Anyway, if you are not able to solve those questions, you are not losing any marks. You have to take a guess. How can you take a guess? Either you take a guess randomly, okay, or you do a strategy that, okay, I will use this strategy during the exam. Okay, so this is how you should approach. You might be wrong, obviously. In between, suppose the answer is 2, you marked it 3, then also it is wrong, right? So this is not a very good strategy, but it is a good strategy. Okay, it's not very good foolproof strategy. Then if it is a foolproof strategy, everyone will be finishing the exam in 5 to 10 minutes and they will go home. But that is not right. So it is a strategy. If you are not able to solve a difficult critical question, those questions you can take this strategy. This is a strategy. This is not a foolproof system. Okay. Okay, anyway, I hope that you will remember the things that I have said, okay, and all the best. See you after the exam. After the exam, chemistry ma'am will come with a quick revision for just before your exam. There will be a quick revision for chemistry as well, and then I will be back with the paper discussion of your physics paper. Okay, till then, bye. See you later in the evening.